speaker this evening is visiting us from the Moses Lake Postmasters Club. He's completing project number 8, Get Comfortable with Visual Aids from the Confident Communicator Manual. Please help me welcome Tom Bennett, as he presents his speech entitled The Blue Flash.
Thank you, Dean. Blue flash involves radiation. I'm hoping to give you a rudimentary education in radiation. Do any of you old-timers remember when you bought a shoe or a pair of shoes, you look in this thing, you can see your bones? That was a radiating thing. If you, in one instantaneous flash, get 450 R, or Roentgen equivalent of radiation, that's called LV50. If you get 450 rads, 50% of the people will die in 30 days. It tears your insides apart. Now, many experiments were done early on. I went to Hanford as a nuclear engineer many, many years ago, and I'd only been there for a week or so when a couple guys came up, and each of them gave me a cylinder, and they told me there was enough plutonium in that cylinder to kill 500,000 people. One in this hand, one in this hand. Well, naturally, I wanted to bring them together. They grabbed my hands, took them apart. Apparently, they did this to everyone. They said, if you put those two cylinders together, you're going to see a blue flash. That's prompt critical. The neutrons that are flying out of that will kill you. You won't tell your wife goodbye, and that'll be it. So I was interested in the blue flashes. 3 or 4 months later, I got assigned to operations. These are the radioactive elements that go through a reactor. Reactors are 40 feet by 40 feet by 40 feet. They have 1,004 tubes in them. Those tubes are filled up with uranium. Now, here is a softball which has a diameter of 3.5 inches, if I can get it out of the pocket. This, if it were plutonium, do you know how much it would weigh? Anyone want to guess? 3.5 inches diameter.
38 pounds.
Very, not bad. 16 pounds. For each 2,000 pounds of uranium that goes through a reactor and gets irradiated, 1 pound of plutonium is produced. In other words, it would take 32,000 pounds of irradiated uranium to make a sphere of plutonium that big. And it was a sphere of plutonium about this big that blew up Nagasaki. I'm going to tell you about 2 experiments that physicists did in the 45 or mid-40s. One of them was a small table that had tungsten carbide blocks on it, and one of these spheres of plutonium was in the middle. It was almost enough to go prompt critical, but the tungsten carbide blocks reflected neutrons, and they were building a wall around the plutonium. The main investigator dropped a brick. There was a blue flash. He moved the brick away as soon as he could, but 21 days later, he died. Now, the next experiment is called tickling the dragon's tail. One of these, the same sphere that was used in the tungsten carbide experiment, was cut in 2, so it was 2 hemispheres. And one half of the hemisphere was lowered to the other half. And if you think of it like an orange, plutonium was the 2 hemispheres, and the orange peel was beryllium. Beryllium is a light metal, but it reflects neutrons. So there were 7 people in the room, about this size. If that black thing is where the experiment is, Dr. Slotkin was on top of it. There were 2 people about where my camera is. There were 2 more people where the evaluator is. The last 2 of the 7 people were as far back away as they could be. There are radiation monitors all over the room. The experiment was not high-tech. He was lowering the upper hemisphere to the lower hemisphere with a screwdriver. Does that sound smart for a PhD intelligent guy? The screwdriver slipped. The top half hit the bottom half. A blue flash came out. The experimenter removed the top half and bottom half as soon as he could, but he received 1,000 R. In 11 days, he had died. The people that were 3 or 4 feet away, the side of them that was closest to the blue flash was paralyzed, and they probably eventually got cancer. The people that were there got some radiation, but it wasn't that bad. The people that were as far away as they could got very little radiation because of the inverse square law. If you're 4 feet away, you get 1/16 as much irradiation as the ones that are 1 foot away. Another interesting experiment took place at the EWR reactor in Idaho. If the manually lifted control rod, which had boron in it, if it was lifted 11 inches, the thing would go prompt critical. What happened was there were 3 operators in there. 2 of them were Army, 1 was Navy. It turned out that one of those operators was carrying on with the other one's wife. So the guy pulled the reactor rod up 21 inches, went prompt critical at 11. The reactor blew up, killed all 3 of them. So the moral of this rudimentary lesson on radiation is, if you go to Hanford, if you go to Oak Ridge, if you go to Los Alamos, the Liver or Radiation Laboratory, ask them about blue flashes. You'll get an interesting response. Thank you.